So the final part of problem 6, this is another example of a problem where you're asked to do logarithmic differentiation. In this kind of problem, you don't have to do logarithmic differentiation, but it definitely will make this problem much easier, because if you tried to do product and quotient rule using this, you'd run into a lot of headache because these functions get really complicated. So whenever you have a product and quotient of 3 or more types of functions, so we have an exponential function, we have another thing here raised to the third, and on the bottom we have a root. If you have 3 or more functions in some fraction, generally logarithmic differentiation is going to be a good idea. So the reason we want to do that is because the log rules allow us to break up those pieces once it's in a ln. So just like every other thing, when we do logarithmic differentiation, we take the natural log of both sides first. So we get ln y equals. So I'm not going to rewrite this whole thing, but notice that if you took ln of this entire fraction, you would be able to use your product and quotient rules of logs to split these up. So anything on the numerator is going to be positive. Ln of e to the 3x plus 1 plus ln of x squared plus 3 cubed. And then the term that's on the denominator is going to be minus because of your log rules. That's going to be, I'm going to write that as a power, 2x minus 1 to the 1/2. So by doing the natural log, we're able to break up all of these things because of our log rules. So again, now before we do the derivative, we can apply other log rules to these by using the powers. So in this case, ln of e to the 3x plus 1, well, that's just going to be 3x plus 1, because when you bring the power down, ln of e is just 1. Here we can bring the power down and become 3 ln of x squared plus 3. And here we can bring the 1/2 down and be minus 1/2 ln of 2x minus 1. So you can see now we got this as simple as possible. Everything doesn't have powers anymore. We got rid of the e. We did all this stuff to make this as simple as possible. Now we'll do the derivative because this will be the easiest derivative that we can get. Derivative of ln y is y prime over y. So the derivative of 3x is 3. The derivative of 1 is 0. The derivative of an ln term, well, first of all, we have 3 here because the constant's going to stay there. Remember that when we do the derivative of an ln, we just put whatever you're taking the ln of in the denominator, 1 over that, and then we multiply by its derivative because of the chain rule. So in this case, we would get 2x over x squared plus 3. Because x squared plus 3 goes in the denominator, its derivative goes in the numerator, 2x. Okay, and then in the last term we get minus 1/2. Again, we're taking the derivative of an ln, so we put the original thing in the denominator, its derivative in the numerator, which is 2. So we have some things we can do to make this slightly simpler, like this 2 and 1/2 cancel out right here. But other than that, all we can do is multiply over y back over. So we isolate our derivative and that's it. So our derivative, y prime, is equal to y, our original function, e to the 3x plus 1 times x squared plus 3 cubed all over the square root of 2x minus 1 times whatever we had left here. So that's going to be 3 plus, here I'll just multiply the 3 into the top here, so we get 6x over x squared plus 3. And over here, since the 1/2 and 2 canceled out, we just get minus 1 over 2x minus 1. And this last thing I just wrote here, that's our derivative. That's as simple as we can get it. So again, we didn't have to use logarithmic differentiation with this problem, but by doing so, our derivative just becomes some simple algebra and not a really messy thing involving both product and quotient rule.
The Teaching Center, UF's Learning Resource Center.